Hello and welcome to our first Farmanco Precision Agronomy video. Today we'll be looking at how utilising yield maps can help to make more informed and precise agronomic and management decisions on farm to help drive productivity and profitability. When discussing yield maps and their benefits, mostly assumptions are made that this processed data and information is mainly only beneficial for variable rate applications. Although they have a significant contribution to precision ag applications, there is still a wealth of information that can be used to make more refined agronomic and management decisions on farm. As we find today, most machines now have telematics capable of providing real-time information on crop productivity as we harvest. As we progress through this harvest, all this data that is collected is assigned its own spatial referencing point that we can then use when referring back to with spatial analytical software, as we'll see later on in this video. As each of these data points are logged, we can start to build a spatially referenced map, generally referred to as our base map. Within each individual data point, all attributes collected by the harvester are available to view in our spatial mapping software. By selecting one of these attributes, using yield maps in this scenario, each of the data points then display their reflected data in the format that we can adjust depending on our own preferences. Swath maps display the collected data based on the designated swathing width originally set up in the harvester. This helps to display the information spatially without the need of interpolation. The use of interpolation, this data can be viewed in either a grid format or a contoured map. The use of interpolation helps to fill in spaces in between the data and help refine the visual maps for clarity or reducing the complexity of applications going forward. Cleaning yield data is a process that is generally needed as calibrating harvesters in the field can still leave discrepancies between what data has been collected by the displays versus actuals. By recording actual tonnes extracted from fields, we can simply adjust the data through quick analytics to better match actuals extracted. As we can see in this example, by comparing the display data with the actuals, we have simply applied a conversion ratio to adjust the data to match actuals delivered. It's important to know also that even uncalibrated or non-clean yield data provides the same insight into paddock productivity performances as extraction rates remain consistent regardless of actual tonnes extracted. Displaying the yield data is important to help identify aspects of the information we want to view more clearly and precisely. Our base swath map is generally our first view of yield information once extracted. Here we have an overview of yields by various reference yield ranges or zones. These are generally displayed in equal splits by hectare. This map can then easily be switched between viewing as a contoured map or as a grid map. When we reduce the number of yield zones down to 3, we can see the interaction that each map has on displaying this data. With the number of zones decreased, the range in each of these values increases, again over an equal distribution by hectares. This can help to start to distinguish paddock variability and looking at these splits as either high, medium and low production zones. We can also manually determine how each of these zones are represented by assigning yield range values or adjusting as a percentage, as seen when we increase to 4 zones with a 10% allocation to the very high comparative yield range and 30% for each of the remaining zones. For easy viewing, or for the reducing the complexity of these maps, we can adjust the interpolation settings on these contoured and grid maps to further smooth out areas by adjusting the settings. We can see this as we adjust the following settings from the default 6.65 meters to the 25 by 25 meters. By defining the yield zones to set yield increments, we can then start to look at comparative yield maps between different fields and/or seasons. As we see in this example, we have set the yield zones to be in increments of 0.5 tonnes per hectare. Now when we apply this to 2 comparative fields, as in this example, the same field over 2 seasons, we can start to see the production output as a comparison. This can be helpful in determining nutrition extraction values, paddock productivity performance analysis, and a lot more other agronomic and management applications. You can see that when we revert back to our original maps, we can still see that even between 2 different seasons, our paddock productivity or production zones remains relatively consistent. Taking this step further, we can then look at consolidating multiple years, 2, 5, 10 years worth of data into one multi-year analysis map that will generalize the productivity and yield outputs to give us a more in-depth look at where productivity levels are and/or zones have been consistently over the years. Understanding where our high, medium and low production zones are, we can begin to further investigate these areas and understand where our paddock capabilities and/or limitations are and how we can improve productivity and efficiencies going forward. Again, this map can be adjusted to best suit user preferences by increasing the number of zones on paddocks with higher variability or adjusting the way in which the information is simply displayed and utilised. An example of how we can start to utilise this data can be seen in the following examples. When distinguishing the yield extraction rates over a single season and at various set yield increments, we can then use this information to assign nutrient extraction rates based off crop types and their associated nutrition extraction values per tonne. With this information, we can spatially map out nutrition extraction maps and utilise this spatial information to determine the extraction rate splits by hectares and by percentages. This can assist later in determining optimal input strategies in the following season's crop planning. By being able to spatially identify high and low nutrient extraction zones or areas, we are also able to more precisely target soil sampling locations to further investigate these areas and identify their current soil limitations and or verify current nutrient levels for further input efficiency planning. Other examples of utilising yield data at set yield increments is assigning it in comparison with other available data sets. An example of this would be water use efficiency maps based off known rainfall data. With this data, we can correlate the following yield information to rainfall and build maps looking at water use efficiency spatially in paddocks. These maps also have the capability to segregate and isolate particular sets of data to further analyse or reference single pieces of information only. Another feature when looking at yield maps is the ability to overlay certain map types with one another. A classic use example of this is using the elevation data provided by the machines to map out paddock topography and use this when analysing additional maps. A notable benefit in this scenario is correlating elevation maps with yield data under years of known or observed frost damage. In this scenario, we can map frost susceptible areas and assess paddock risk by percentages. The map overlay feature can be applied to all map types and used in multiple different mapping scenarios. In more advanced precision ag analytics, we use this feature to start correlating yield, biomass and soil data to determine and build holistic paddock production and analytics for refining VR applications and improved agronomic assessments in season. Where paddock production financial data is known, we can then start to collaborate this information to build financial maps that can distinguish break-even points in paddocks and even outlay the profit and loss spatially. With this information, we can then begin to understand where economic losses are occurring and then address these areas in our agronomic and management planning phases to improve overall paddock financial performance. Once we have processed and completed these maps, we have the capabilities of using these as references when in the field in the following seasons, whether or not it's for more thorough soil site selection and analytics, which is using to reference areas of known high and low production and assessing crop developments in season. In conjunction with readily available biomass imagery in season now, we can use a combination of these maps and resources to more effectively drive our agronomic assessments in-field at any point within the season. We've merely scratched the surface here in what we can do with some of our spatial data, but hopefully I've been able to provide some insight into the benefits of having yield data analysed for those that are not yet thinking about applying variable rate on farm. If you're interested in any of the applications discussed in this video, would like to simply discuss how precision agronomy services can help boost productivity on your farm, then feel free to contact one of your local Farmanco consultants today.